Hey everyone, and welcome back for another deep dive into the tech world. You know us, we like to get into the nitty-gritty of things in tech, so today we're tackling something that's everywhere, but a lot of folks find kind of mysterious.
Yeah, AI algorithms.
AI algorithms, exactly. We hear these words thrown around all the time, but
Yeah.
do we actually know what they mean?
I think for a lot of people, it's kind of a black box, right? Like
Oh.
magic happens and cool stuff comes out, but who knows what's going on in there?
Right, so we're going to try to demystify it a little bit today, starting with some of the most important algorithms that are out there.
Perfect. Let's get into it.
Okay, so first up is one that everyone seems to mention when they talk about AI, but it doesn't sound very exciting. I'm talking about linear regression.
Linear regression, yeah. It's kind of the workhorse of a lot of AI applications, even though it's been around for, well, forever.
So what is it in a nutshell? Can you give us a real-world example of how it's used?
Sure. So think about trying to predict something like, how much your house will be worth in 5 years.
Oh, that's relatable. Everyone wants to know that.
Exactly. So linear regression looks at the relationship between different variables, like the size of your house, the location, the age, and how those things have impacted housing prices in the past. And then it uses that information to draw a line, basically, that projects what might happen in the future.
So it's kind of like a superpowered trend line then.
Yeah, you could think of it that way. It's connecting the dots, but with a bit more mathematical sophistication.
I'm sure. But wouldn't something like that be really sensitive to outliers? Like, what if there's one crazy expensive house that skews the whole prediction?
That's a great point. Linear regression can definitely be thrown off by extreme values, so it's important to understand the data and its quirks, but that's true for any algorithm, really.
Yeah, makes sense. So besides predicting house prices, where else do we see linear regression in action?
Oh, it's used in tons of places, predicting website traffic, figuring out how many tacos a food truck might sell based on the weather.
Okay, now you're talking my language.
Right. It's surprisingly versatile.
All right, so linear regression, the classic, but powerful. What's next on our AI algorithm hit list?
Let's talk about logistic regression. Now, this one sounds kind of confusing because it's actually about classification, not regression.
Wait, what? So the name is a lie.
Huh? Yeah, kind of. Think of it this way. You get an email, and your inbox has to decide, is this spam or is this legit? Logistic regression is the behind-the-scenes hero figuring that out.
Ah, so it's a spam fighter.
Among other things, yeah. It estimates the probability of that email belonging to one category or another, spam or not spam in this case.
So it's more about sorting than predicting then.
Exactly. It's a key player in a ton of AI systems, from medical diagnoses to those personalized recommendations you see online.
Oh, I see. So it's kind of laying the groundwork for understanding even more complex classifiers then.
You got it. It's a fundamental building block.
Okay, so we've got the predictor, we've got the sorter. What's next? Hit me with another essential algorithm.
Let's get visual and talk about decision trees.
Decision trees, sounds intriguing.
They're pretty cool. They're all about mapping out decisions and predictions. You can actually picture them like a tree with branches and leaves.
Oh, so like if this, then that kind of thing.
Precisely. It starts with a question, branches out based on the answers, and eventually leads you to a final decision or prediction.
So if I'm trying to decide whether to have that extra cup of coffee, the decision tree could help me weigh the factors, like how much sleep I got versus how many meetings I have.
Exactly. It's about systematically evaluating the different paths. And what's cool is that these trees can be combined to make even more powerful models.
Okay, we'll have to dive into that another time maybe. But so far we've got our predictor, our sorter, our decision maker. What else is there?
Let's talk about finding your data tribe with k-nearest neighbors, or KNN for short.
K nearest neighbors. Okay, that sounds friendly.
It is. This algorithm is all about grouping data points together based on their similarities. Imagine a popularity contest where data points vote for their closest buddies.
So like my social media feed, but for data.
Pretty much. KNN is great because it doesn't need any prior training. It just jumps in and starts analyzing.
Oh, so it's a go-getter. I like that. But I bet there's a catch, right? Nothing's perfect in the world of algorithms.
True, it can get a bit computationally expensive with massive data sets, but it's a really valuable tool, especially for beginners because it's pretty intuitive and easy to grasp.
All right, so we've got algorithms that predict, classify, map out decisions, and find data soulmates. What's left in this fascinating world of AI algorithms?
So we've talked about a bunch of algorithms now that kind of rely on us telling them what to look for,
Yeah.
right? Like giving them labeled data and saying, okay, here's what a cat looks like, here's what a dog looks like. Now go figure out the rest. But there's a whole other world of AI where we let the algorithms kind of discover things on their own.
Oh, you mean like letting them loose in the wild? Sounds a little risky.
Haha, yeah, well, maybe not that wild. But the idea is we give them data and we say, go explore, see what patterns you can find. This is called unsupervised learning.
Unsupervised learning. Okay. So it's like those aha moments you get when you suddenly see a connection that you didn't notice before.
Exactly. And one of the most popular algorithms for this kind of learning is called k-means clustering.
K-means clustering. Okay. What's that all about?
It's all about grouping similar data points together based on their characteristics. Like, imagine you're a marketing guru and you're trying to understand your customer
Oh,
base.
yeah, and that's a good example.
So you could use k-means to group them based on their purchasing habits, demographics, even social media activity.
It's like finding those hidden tribes within your customer base.
Exactly. It's like having a virtual sorting hat for your data.
A sorting hat. I love that analogy. So K-means is like the master organizer of the AI world. But what if we want to go beyond just grouping things together? What if we want to get into, like, the really mind-blowing stuff?
Then we got to talk about neural networks.
Ah, neural networks. The ones that are always in the headlines, beating grandmasters at chess, writing poetry, composing symphonies.
Yeah, you're not wrong. Neural networks are capable of some pretty amazing feats. They're inspired by the way our own brains work, with layers of interconnected nodes that process information.
So it's like building a digital brain.
Kind of, yeah. And by adjusting the connections between those nodes, the network can learn incredibly complex patterns. That's why they're so good at things like image recognition, natural language processing, even predicting stock prices.
Okay, so it's like training a digital brain, but this brain can process information way faster than our squishy human brains can.
Exactly. And there are actually different types of neural networks, each with its own strengths. Like, some are great for image recognition, others are better for processing language.
Wow, it's like a whole ecosystem of AI brains, each with its own special talent.
You got it.
That is pretty wild. But before we get too lost in the neural pathways, let's talk about another powerful tool, something called random forests.
Ah, random forests. These are like the ultimate example of teamwork in the AI world.
Teamwork. How so?
Well, they combine the power of multiple decision trees, remember those, to create a super predictor.
So it's like having a panel of experts, each with their own unique perspective, coming together to make a decision.
Exactly. Each tree is trained on a slightly different subset of the data, so they all bring something unique to the table. And that makes the overall model way more robust and accurate.
So they're like the all-star team of AI algorithms.
You could say that. And they're super versatile. Good for classification, for regression, anything you throw at them. Predicting customer churn, spotting fraudulent transactions, even diagnosing diseases.
Okay, so we've covered a lot of ground here. From the simplicity of linear regression to the complexity of neural networks and the collaborative power of random forests. It's amazing to think how far this technology has come. But I got to ask, what does all this mean for the average person? How is AI actually impacting our lives?
That's a great question, and one we should definitely dig into a bit more.
So where were we? Ah, yes, the big question, how is all this AI stuff actually impacting our lives?
Well, I think it's safe to say that AI is already having a huge impact, even if we don't always see it. Think about those personalized recommendations we get on streaming services, or the spam filters that keep our inboxes from overflowing.
Right, right. And we talked about all those other applications like fraud detection, medical diagnoses. It seems like AI is kind of sneaking into every corner of our lives.
It is, and it's only going to accelerate from here. But I think the key thing to remember is that AI is a tool. And like any tool, it can be used for good or for, not so good.
So it's not the algorithms themselves that are inherently good or bad, but how they're used.
Exactly. Like, take facial recognition technology. On one hand, it can be used to improve security or help find missing people. But on the other hand, there are concerns about privacy and potential misuse. It's a tricky balance.
Yeah, it seems like with every new technology, there's always that trade-off. More convenience, but maybe less privacy. More efficiency, but maybe fewer jobs. It's a lot to think about.
It is. And that's why it's so important to have these conversations, to be aware of the potential impacts, both positive and negative. We can't just blindly adopt new technology without considering the consequences.
Okay, so if there's one thing our listeners should take away from this deep dive, what would it be?
I'd say don't be intimidated by AI. It can seem complicated, but as we've seen, the basic concepts are actually pretty easy to grasp. There are tons of resources out there, online tutorials, videos.
You can even find interactive demos that let you play around with different algorithms.
Exactly. The more you understand AI, the better equipped you'll be to navigate this crazy, rapidly evolving tech world we live in.
Knowledge is power, as they say, especially in the age of AI.
Couldn't agree more.
Well, that's all the time we have for today, folks. Hopefully you're feeling a little bit smarter about AI algorithms now.
And a little less intimidated, hopefully.
Exactly. So stay curious, keep learning, and as always, thanks for tuning in to Tech News Now.